Today, we're going to be talking about Internet of Things and how to get your network ready for this new era of technology. To talk about this topic today will be our product line manager, Xavi. And you can take it away, Xavi.
Thank you, Sarah. Welcome, everybody. This is Xavi. I am the PLM here at NETGEAR for Manage and Blast Switches. And today, as Sarah said, we're going to cover an exciting area. That's the IoT. So what we're going to see today is how we can be ready for the new IoT era. And what I'm going to cover is how important is the IoT era, how it's going to change the way that we manage our networks, and how it's going to change our networks in the near future. So it's kind of a preparation, so I hope that you guys will enjoy it. So the topics in the agenda for today, it's going to be first, we're going to do an intro about the IoT. It's just going to be a little bit generic. Later on, we're going to start working on the IoT network. So how it's going to look, this IoT network in the future, what kind of components we are going to have in the IoT network. So that's one of the areas that I would like to highlight. And there are three areas where we really want to make sure that when we implement a network, and if we want that our network is going to be ready for the IoT, we need to consider. So these three areas are scalable, so the network has to be scalable, reliable, and secure. So that's the three main points that we need to consider when we are designing or when we are implementing any network that want to support IoT in the near future. So just to let you know, normal network, it runs around 5 years, more or less 5 to 10 years. So yeah, and we expect that the IoT gonna take off in the next 2 years. So yeah, it's time to start thinking about it. So let's start with the presentation right now. So first of all, is about introduction of the IoT. As I said, the first thing is about what is going to change on the IoT network. What is the main change that we are going to see? Mainly, it's going to be the number of devices connected. So we expect that we are going to have 20 billion connected devices. That's massive. I remember when I started working on IT, normally for doing a design on an SMB network, we used to have, for example, if a company got 5 people, we used to say, if you have 5 people working here, you will need an 8-port switch, so 5-port, 1 per person, and we have some extra capacity to grow. So that was probably 10 years ago. Currently, as you guys know, that already changed. So now we have phones, we have access points, we have printers, we have also cameras. So normally now when we are designing a network, if it's for 8 people, we need a 24-port switch, because 24 ports, because we need all these extra devices that's going to be connected. However, that's just the start point, and that's what I want to highlight. This IoT is going to change this perspective, and what we expect is that the number of devices is going to be exponentially growing. So we expect that in the next 4 years, we are going to almost multiply by 4 the number of devices that we can see connected in our network. So get ready for that. Imagine now we went from the 1-to-1 to 3-to-1 and probably 12 to 1 device in 3 to 4 years. So as you can see, the networks are going to get bigger, and we're going to need to be prepared for that, because it's not the same to design a network for 5 devices than a network for 20 than a network for 80. So that's what IoT is going to be really important and going to impact in the way that we design and we manage our networks today. So what else is going to impact the IoT area is also it's going to change the way that most of the industries work. I will not cover all of them, but to let you know, guys, there is IoT applications for retail, there is IoT applications for healthcare, there is for education, for industrial, for manufacturing. So almost all the different verticals going to be impacted in this IoT era. So just to let you know, like an example about the IoT area in the shopping center is automatically when you enter into the shopping, you gotta be scanned, and the system will know like your preferences, what you need, what you used to buy. So that's gonna be automatically done. Automatically also like the different products on the shelf gonna be able to ping you, like to talk to you, to let you know, like, hey, I know that you bought me like 2 weeks ago, so are you sure that you don't want more of this product? Also, it's gonna impact the way that we pay. Probably we will not have to go anymore to the cashier, to the counter and pay. Probably it's gonna be automatically done through the RFIDs and the different systems that we can implement. And the last point is also about the way that we are going to manage all these infrastructure. So it's going to be a lot of data that we are going to need to manage. So that, for example, just IoT in a retail shop, like the impact of these IoT devices in the retail shop. But the main concept here that I would like to highlight is the sensors area. So why we expect to have this increasing number of devices connected to our network. So mainly it's because in order that all this technology, the shopping or the healthcare or any of the different industries works and improves, it's about the sensors. So that's like what it's impacting the number of devices that we are going to have in our networks. And currently, we can have sensors about, for example, electric, magnetic, leaks for water, flows, chemical, gas sensor, acoustic sensors, humidity, temperature, motion. So there are a lot of new sensors and a lot of new devices that needs to be installed in order that these new applications work. So that's why the IoT network gonna have like all these devices connected all together. So now we're gonna start talking about how it looks an IoT network. So get like a little bit more into the IT area. So how it's gonna look our IoT network. So this is a good graph that we created. It's the IoT architecture for SMB. So normally, what we have today, we have our IP network where we have our switches, and normally what we connect to these switches are our NAS, for example, a storage device, printer. We also connect, for example, a desktop or a laptop into our IP network. And we also have like the cloud connectivity. So we have, for example, some services, can be like on-premise or can be on the cloud. We have different devices here and also on the cloud. However, that's almost where it finished. And now what we're gonna see like in our area, we added two new parts. The first one is the sensors. So that's an area that we don't have it, or we have like a small portion right now, and that's the one that it's gonna increase a lot. So these sensors gonna need to be able to communicate to our IoT gateways or access points. What I put access points, because the access points are gonna be also some of them an IoT gateway itself. So how it works, so these IoT gateways, they have different connectivity methods to be able to allow these sensors to talk to the IoT gateway. What are these different kind of connectivity? We will talk a little bit later, but mainly you have the Z, that's the Zigbee, you have the Bluetooth, low energy, you have the NFC, and you have, these are like mainly the three ones that requires the IoT gateway. So the IoT gateway, what they have is for one interface, for one side, it has Zigbee, Bluetooth, NFC, but from the other side, what it has is the Ethernet. So that's the area that's connected to our network side. If we go a little bit further, we can see the IoT gateways here and there, but we also see access points. So access points, some of them you're gonna see that that will come with Bluetooth, low energy, and Wi-Fi, or Wi-Fi and NFC. So like with different technologies. Unfortunately, we're gonna see in the next slide that the requirements in terms of distances are different from the different technologies. Okay, so that's something that we are going to see. So it's not the same cover. We have different requirements if we want to provide, for example, a Zigbee coverage to an area that if we want to provide Wi-Fi coverage. But we will have a look on this one a little bit later. However, the access point is going to be also now part of this IoT because they have like this connectivity that could be NFC or could be Bluetooth. And moreover, we are going to have some of them going to have Wi-Fi, and some of the sensors going to be Wi-Fi. So the Wi-Fi itself going to be like the number of devices that are connected through our Wi-Fi going to increase because some of these sensors going to be connected through regular Wi-Fi. And not the last ones, but not the less important, are the sensors that they also going to be able to connect directly to our Ethernet, because in some cases, like it's going to be interesting for us to have sensors that work directly with the IP network. And thanks to the PoE, like for example, right now it's already a reality. Door controllers, they are PoE devices that are that require a wired Ethernet cable, so they are connected directly to our IP network. And thanks to that, we are able to open the door, have a look what is the status, monitor it. So that's the last part of these sensors, that they are also going to be connected through our IP network. And here we are still going to have our computers, our printers, our servers connected to our IP network. So that's why our cameras. So that's why I said like that right now we are talking a ratio of 3:1. Normally when we are designing networks, as I said, if we have to design a network for 5 people, we normally ended up with 15 ports used, and we use a 24 port due to that escalation. But now we're looking like at the 12 devices per one person, and that's what we expect in the next 4 years. So imagine 5 people gonna require already 60 ports, so 60, like a network that supports 60 devices. Some of them Wi-Fi, some of them wired, but like just to let you know, remember this factor, 4 times more than what we see today. So like the embracement of the mobile devices, it's been good, but imagine multiply by 4 this number of devices connected. So that's what I really want to reinforce. I hope that this architecture is clear. And the last point that I would like to highlight is that all these IoT sensors and gateways, normally all of them, they have a cloud system that, because to be able to analyze all the data, it requires like quite powerful systems. So normally the different IoT vendors and sensors, they provide us like a cloud system to be able to analyze all this data. So the internet connectivity to that sensors are critical. So that's the other part that we are going to see, but it's one of the main reasons why we want that this IoT network has to be reliable and scalable. So that's because the connectivity is crucial when we are using the IoT network. So moving forward, that's the architecture. Just as I highlighted before, I want to give you guys a quick update about the different networks and the different sensor connectivity. So here we also have the wired connectivity, but the wired connectivity is easy because it's Ethernet. So Ethernet can run to from almost 0 meters to 100 meters or even longer with fiber. So that's the wired. The wired, it doesn't have much specifications to say. Just to let you know that we have like now the gigabit and the 10 gig, so we have like higher speeds there. But for the wireless, just to let you know, yeah, NFC, the main part that we have to realize is the distance, or depending on the distance that we want to cover, like we have different technologies. So from the speed and the distance, so we can see like what's the range and the speed. So from the range, like NFC has a range that's really limited, but and a speed that's limited, but it's really good for low for applications that's really like close to the device because it doesn't require any power. So here it should be a three-dimensional. That's the power requirements. So power requirements normally, as you have more distance and more throughput, power is also it goes up, and that means that we need like a higher batteries, and the device will not be that small. So that's the other part. But just to let you know, the main technologies that we expect to see on the sensor side is NFC, Zigbee, Bluetooth, and some proprietary technologies, some cellular here, and Wi-Fi, as you see. So some of the Wi-Fi, and specifically with some new Wi-Fi standards like the 8H, that is for the low frequency and higher range. We expect to see like also sensors using Wi-Fi. So that's the thing, like when you guys design the IoT network, you have to think about, for example, which kind of sensors you're going to use and what's the IoT gateway that you're going to require. So it's going to be like a Bluetooth, Zigbee to Ethernet, going to be only 100% Wi-Fi. That's also going to change the requirements of your network. So saying that, we can move forward. Here, let me just clear the notes. Okay, so just to make sure we understand the components related to the IoT network. So first is the sensors. So the sensors, as we said, could be Wi-Fi, Bluetooth, Zigbee. Two things that we would like to highlight is that could be embedded. That's also something that we don't have to forget. Like, for example, our smartphone, it's a big sensor. And that's like most of the apps are now currently using our smartphone as a sensor, for example, where we are for tracking us, or for even like for temperature, or even for other devices, because we have camera, we have a lot of different mechanisms in our smartphone that can be also used as a sensor in our network, or can be accessories. So it's, like can be like a light, can be like, for example, a temperature sensor, can be like a lot of different types of sensors. The gateways, so the gateways is the other part, can be standalones, as we described it before. So standalones are the ones that only does Zigbee, Bluetooth, but they don't do Wi-Fi, or can be embedded in the access point. So when we implemented an access point, we could look at, for example, having Bluetooth or Zigbee in the same access point, so we can provide connectivity for these sensors. And the last piece, but not the less important, is the cloud. So we are going to have cloud, where we are going to have public and private cloud, and big data is going to be like really important to be able to analyze all the data that all these sensors are going to send us, and the monitoring of all of those. So that's how like we are going to be able to provide these automated network systems, and that's the kind of architecture that we have to think about it when we plan to implement networks today for the IoT network. So just to let you know, we are moving from voice, video, data networks that we have today to the IoT era, where you can see like I even put like the names on it, because it's like many different layers, many different types of applications that you're gonna see here. So from, as I said, from healthcare, from the education system, so everything gonna be impacted from the IoT area. And you guys, you can see already on our networks how this area is impacted. So we are going to cover, just to let you know, guys, yeah, feel free to ask the questions. If you don't mind, we are going to cover all of them at the end. But yeah, please feel free to use the chat and add any questions in the chat. So at the end, we can talk about all of them. So what are the network requirements for the IoT? So mainly there are three network requirements that we have to make sure that we cover when we implement a typical IP network. So first, as I said, like the network has to be scalable. So as you guys saw at the beginning, we are gonna multiply by 4 the number of devices that are gonna be connected. So yeah, it's kind of a mandatory requirement that we design a scalable network. Otherwise, it will not work. Reliable, as we saw, like it's crucial that the network works almost 99.999%. So So the typical 5 nines of availability that normally it was only crucial for the big corporations. Now it's becoming also important into our IT networks, and we are going to tell later how we can build a reliable network and secure. It's really important, security, because in the IoT era, the main thing about security is that as many devices we have, our attack surface, like the number of devices that can be hacked, is higher. So we need to secure. So in a network where we only have 5 devices, yeah, you only can hack 5. But if you have 60 devices, you can hack 60 devices, and some of them they don't have like the capabilities of the same secure capabilities that we have in our current computers or voice systems. So that's also another part. We need to make sure that our network is secure. So we are now going to start talking about how we can design a scalable network to support all these new IoT devices. So the first thing is, yeah, that's a cool picture. That's kind of like a typical network installation, a little bit messy, I know. But, you know, guys, I am sure that it's familiar for some of you, like that you have seen that kind of pictures in your life several times. So that's the thing that I want to highlight here is that the best practices about the network design. So the first thing that we need to think about it is most of the networks, they only have one layer. So we have all the load on the access layer because we only have one layer. So all the switches are together. We just daisy chain them, and that's how we normally work on the switching area. However, that's not the way to do it. So the way to do it, to be able to have a scalable network, is to have at least a 2-tier network. So what does it mean is that I need to break the network into pieces. One is the core, these devices here, and one is the access. Why is that important? Because at the end, if we don't break it, when we have many devices, we cannot implement the security features and the performance features that we require, because at the end, we are going to have all the traffic going to the main switches. So the core switches are the ones who have to be like passing all the traffic as fast as they can, and the access ones are the ones that we need to implement the security, the control. So because that we don't want to block our main core. The main core has to be like passing all the traffic. And currently what is happening is that we put all together and we put all the intelligence on the core. The problem of putting all the intelligence on the core when we have multiple devices is that everything is getting slower. So instead of doing that, we need to make sure that we put the intelligence on the edge, and we have the core as fast as we can. So that requires the VLAN deployment per service also to be able to have this performance. And the other thing is, yeah, please make sure that we don't daisy chain switches. So that's as you know, a common practice. So maximum 2 hops. If we can do it, that's the recommendation. And you know that sometimes you can see like 5, 6 switches daisy chain one to each other. That, as I said, that's not an issue when we have 5, 10, 15 devices on the network. But when we're talking about 60, 70 devices on the network, all of them going to the cloud and getting like messages there, like, whoa, reminds me something that we already saw, like it was in the education space like 3-4 years ago, when we moved from the having like 30 devices in a school network normally, just for like a training, IT training for the students. And now that we moved to the 1-to-1 and even more, like now it's even like 2 devices per student. So we moved from networks that we used to manage with 30 devices to 1,000 devices. So that's the kind of scaling up that we need. And unfortunately, sometimes the network wasn't ready. So we want to avoid this problem here again. So to avoid this problem, the first thing is to design a scalable network. The second step that we really need to be able to design this scalable network. Oh yeah, and reduce the oversubscription. Sorry, I don't want to forget this one. So reduce the oversubscription. It's really important to be scalable, because here, if we have, for example, let's say 24 devices, and we have per 1 gig. So, and my uplinks are also 1 gig. What is going to happen? It's a bottleneck. We are trying to send a possible 24 gigabit to a 1 gig pipe. Yeah, that's a bottleneck. So we need to start using as much as we can the 10 gig uplinks, so we don't have this oversubscribed network. So everything's going to be faster. So that's some of the best practices that I want to share. And just to remember you guys, like these 2 tiers, that's what we really need to start thinking about when we are designing networks, core and access. Even though the network is it's not huge, we need to start thinking about having the core and the access. So core, where the core should be the switch where we use to interconnect the different switches, and we only connect to the core, like for example servers or other devices that are aggregating traffic, for example the PBX or other devices that or the MBR, some devices that are aggregating traffic, but not we should avoid to connect any end device onto the core. So that's the first rule in a 2-tier. Never ever connect any end device into the core. Okay, so that's one of the recommendations. And if we move further and we start having even more and more devices, probably we are going to look to have a 3-tier network. And with a 3-tier network, that's going to be like even bigger. So we're going to have like this access distribution core. But for now, I think that it's more to start thinking about the 2-tier network designs as soon as possible. That's the first big step to be able to deploy the scalable networks. The second point is the reliable network. So how we can ensure and assure that the network is going to be reliable. So the first thing is that normally, as we discussed before, our switch is the single point of failure. So that's kind of like the normal topology for a network. So we have a switch, and we connect all the different devices to our switches. We connect the phones, we connect the cameras, so we connect the door controllers now, for example, with the IoT. Okay, but what happens if one of these links or one of these switches fails? Normally, all the entire network goes down. And in the past, that we only used to have computers will only affect the computer system. But now that we will have all these IoT, video, voice systems, yeah, all the entire network gonna go down. You cannot do anything. You can almost like all your systems gonna be impacted. So the impact of having downtime in an IoT area on the network, it's almost like having to like zero systems working. So that's what we really need to make sure that it works well, and we add the redundancy. Also, yeah, imagine door controllers. If the IT network goes down, even you cannot enter into the into the building. So that could be like even really bad. Or for a company, a POS terminal, that it doesn't work. You cannot even like invoice, or the people cannot pay you. So that's terrible. So yeah, we need to make sure that the network is really reliable. And something that we really need to think about it is the impact of a downtime. So what happens if my switch goes down? How can I add redundancy to this network? So to have a look in terms of the redundancy, let's start looking, for example, to the link redundancy. So normally, as you guys know, if you create like if you put like 2 cables between 2 switches, you're gonna create a broadcast, and the network gonna go down normally in 10 seconds. So the first thing is to think about how I can create link redundancy. So how can I add this link redundancy to be able to work with all the different switches? So there is 2 ways to do it. So mainly, the first one is the spanning tree. So you can have this spine tree. There are many multiple standards, and and one of the things that you have to consider is that the time to take to recover the network is around 1 minute. Okay. And the other one that we also have implemented in our switches for link redundancy is the link aggregation, or LACP. So this is a standard. It's good because as a standard, it works with almost all the devices. So also like from servers and from switches to other switches, you can use it. And the good thing of the LACP or link aggregation is that sub-second convergence time. So what it does mean is that in less than a second, the network or the cable is going to be up again. So that's going to be really, really fast. So one area to add redundancy, link redundancy. Second area to add redundancy is in terms of logical redundancy. So logical redundancy, when I am saying logical redundancy, is how can I have like two switches working together, like and if one of the switches fails, like my network still works. So how can I add this kind of redundancy if one switch fails? So we have three main ways to do it. So the first one is stacking. So stacking is we have this virtual chassis architecture. So we have two 24-port switches, but the reality is that they work together as a 48-port switch. So what happens is that if one of the switch fails, if I have link redundancy, nothing gonna happen. Like all my traffic will work, and I will be able to send my packets, and I will be able to my network will continue working. So the impact will be minimal. We also have the MLAC and the BRP. So there are other methods to do this solution, this logical redundancy. So MLAC is one of those. So that's it's called distributed lag. And the BRP. So BRP is more like in the routing area, so we can provide redundancy. So stacking is a proprietary technology, so you only can stack, for example, NETGEAR switches with NETGEAR switches, and also they have to be like the same kind of models, so the same kind of series. That's the main limitation. MLAC and BRP are, I will say, open. Like MLAC is not really open standard, BRP yes. So for BRP, you can have like the two networks working, and you can like have redundancy. The only issue that I will say for BRP is that you have to also implement the layer 3 network, so it's not a layer 2, so it's kind of more complex to be implemented. So just as to highlight, stacking, easy to use, high redundancy, only issue is that you have to use the same kind of, like it's not multi-vendor or multi-protocol or open architecture, but it's the easy one. And if we go down, more complex it is, but it's open, okay? So here it's a little bit your choice. My preference, I will say for SMB, stacking by far. Like I will use the stacking. So if we add these two technologies together, how it's gonna look our network. So that's the kind of like a network that we want to implement here. So remember the core layer. So these two switches, there is two switches all together, all of them, both of them stacked, and we have the access switches here. These are both of them also stacked. We can also stack the access switches, and we have like this, for example, 3-4 cables going from the access to the core, but they are link aggregated, so they work like as like if it was only one cable. So the good thing here is that all the cables are active, so we have also load balancing. And also good thing is that we have sub-second convergence time. So if one switch fails or one cable fails, in less than a second, we will have like all the network back. And the last point is that we will reduce the number of switches that we need to manage. So in the normal network here, I will have 1, 2, 3, 4, 5, 6 switches that I will have to manage it. Here, we only want to have, if we have some of the architectures, allows us to stack even access and core and distribution, like our M4300. Other ones not. So we will have three, but in some cases we can have like a big stack, like one single point of administration with all these links aggregated. So that's the other part that I would like to highlight in terms of reliability for our network, or resiliency for our network. And the last part is about how we can secure the networks. As we saw, like the first thing, it's like kind of the security threat map, the IoT security threat map that I just wanted to share with you guys. As we saw before, right now in the terms of the security, in terms of network, we add this extra layer that we normally have it in the devices, the edge devices, but now it's huge because we have all these sensors. So you can see that, yeah, it's gonna have like edge devices, networks, also the platforms that we will need to secure, and we're gonna have like different types of threats that we need to protect: authentication, authorization, application hijacking. We're also gonna have like some kind of attacks like ransomware or cyber warfare or cyber criminals. They're gonna try to like hack our networks. And as you saw, like there are already a lot of examples about hacking IoT networks. But we are gonna be working on the network, how we can provide like a more secure network to prevent IoT, because at the end of security, it's always about layers. So as many layers of security that I can implement, more secure are gonna be my network. So that's what we need to think about it when we implement security in our network. So if we move forward, like there are three areas that I would like to talk today about network security. So the three are physical security, logical security, and visibility. So that's the 3 points that I would like to highlight to you guys about how to secure your network. So the first one is the physical security. So what are the different technologies that I will suggest and I will recommend to you guys to have a look? As you can see, this webinar is to introduce you like a lot of different technologies. We are gonna do like also in the future new webinars to explain each one, because each one we could talk like a little bit to let you know how to implement it and how to use it. But just to highlight here, 3 of those is loop prevention, IP MAC spoofing, and port authentication. Let me put some emphasis in the IP MAC spoofing and the port authentication. So IP MAC spoofing is really important. As you know right now, you can test it yourself. Go to any of your networks or your client networks, change the IP address right now, who is the router, put another DHCP server and see what happens. Like you're gonna see that normally what is gonna happen is that directly all your devices gonna be connected to the new gateway. And yeah, if somebody connects to this gateway, gonna be able to see all your information around. So that's the first thing that you need to implement. So in order to implement IP MAC spoofing, we have a lot of different systems to be preventive on that space, like our DHCP snooping or other stuff that are other systems that make sure that the DHCP servers, for example, are only in one specific port. And if you try to add a DHCP server in another port, but it's not allowed, it will block this port, for example. Or if somebody tries to change the MAC address or the IP address, will block automatically this client. The port authentication, that's also critical, is like to identify who is connected to which port. And if somebody connects any other device, we'll block it. So that's the first one is the physical, because we control who is connecting devices to our network. So that's the first one to think about it. Second one is about logical security. VLANs is crucial for security and for performance, as we saw, like in terms of scalability and security, it's the most important one. Why? Because the reality is that as we are going to have these multiple services going through our network, we have these multiple, now one big wire or one network will be able to carry like multiple services. So voice, video, for example, the door controller, for example, the RFIDs, all of them like in the different like logical networks, even that we are running this, we are sharing the same infrastructure. So VLANs is almost like a mandatory point here. ACLs, that's the other area that we can talk about it. ACLs is a firewall, so the switches that also have the capabilities of being a firewall, so we can put like firewall rules in our switches. That's called the ICL. That can be like IP ACL, can be MAC ACL. And the last one is, for example, DOS attacks. So the switches have like signatures that can look at them, at the traffic patterns, and can block any of these attacks, also DOS attacks. The other and the last point for the security, it's about you cannot secure what you cannot see. So that's important message here. So what we need to make sure we implement in our switches is the port mirroring. So port mirroring is a feature that allows us to automatically redirect. For example, let's say that I have a computer A and a computer B, and I send the traffic from A to B, and automatically I can redirect all this traffic that goes to the interface 17 to the interface 11. So for example, if you have a router or a gateway, you can redirect all the traffic that goes through the gateway to another port, and you can use a sniffer like the Wireshark that I'm sure it's quite popular for you guys, that you can use it to capture all these different traffic. And just to let you know, guys, a little bit of our portfolio, the NETGEAR portfolio. So we have like different types of switches that I just want to highlight. Is the unmanaged ones is our starting point, but they don't have any configurations here. It's plug and play. You cannot configure anything that what we set. So I would recommend to start with the web managed. At least they provided to you guys the network control with the VLANs and the network security, a few of the features. But if you want like some extra features, smart managed, like with also with advanced security, and we also have stackable here in the smart managed. And if you want like a future proof, we can go also to the fully managed, where we have all of these features that we talk about it already implemented. So as I said, like this is not a webinar to talk about our portfolio, but I really want to highlight these 3 points of the IoT era of scalable networks, reliable networks, and secure networks. So that was what I wanted to share with you today, guys. And we will go now to cover the different questions that we have. Okay, so let's have a look into the chat. Okay. So Edward is asking us, are there COM standards permitting to client knowledge of what data is coming out of the device, and if the device has embedded technology? I hope the security is strong. I mean, if the device has embedded technology. So some of the devices have embedded technology to be able to send the data, and there are some standards, but the main standards are like the, I will say it's more like for the connectivity standards. So you have the ZigBee, or you have the different protocols to send data. But on top of that, every vendor is implementing their own technology, or their own kind of system to be able to talk to their to their control phase or their managed phase. There are some standards also to allow to talk the different systems between them, but still on the definition area. I think that that's one of the reasons why the IoT still it's exploding, but it's not getting faster. It's because it's not like 100% common standard in everywhere. So for the communications, yeah, there are standards. For the when we go to the management and the control phase, that's where it comes a little bit more difficult. Edward also asked us, please take a moment to elucidate the alphabet soup. Do we talk enough about internal threats from people and devices? You are absolutely right here, Edward. One of the most important parts in the security, it's the as we covered, layer of defense. But the second one, and one of the biggest threats in security, is the internal resources, the internal people that can create security holes. So let's say that, yeah, you can have the best security technology implemented, but if the employees are not trained to use, for example, strong passwords, anybody can be hijacked, and that's the biggest risk. So yeah, we also need to make sure that our employees and the people, we should have a security training for everybody to make sure that they are aware about the possible threats, because some of them they are the only way, or one of the best ways to protect about this threat is about training them.
All right. Well, that's the end of our webinar. Thank you for joining us, everyone. We hope you have a great rest of your day.
Yeah.
Thank you.
Thank you, guys. I hope that you enjoy it. Have a great day. Bye.
Goodbye.